All right, mathletes, here we are looking at sample space and theoretical probability. So we talk about a sample space of an experiment. It's a set of all possible outcomes. What can happen in this experiment? Okay, there's three main ways that we're going to organize and look at sample space. One is lists, one is grids, and one is my favorite, tree diagrams. So let's look at what a list is. Well, it's exactly what you might think it is. Okay, so the simplest way to represent a sample space is to list out possible outcomes. Okay, so if I'm thinking about an experiment where I am going to flip a coin and spin a spinner and get an outcome, I want to list out all the possibilities. Well, I could have a head and I could have a spin of an A. That is one outcome. I could have a head and a spin of a B. And I could have a head and a spin of a C. So when I make my lists, I try and make sure that my set of my list is very straightforward, and I try and organize it in a pattern so that I make sure it's including all possibilities. Okay, so now that I've gotten all my heads, I could flip and get a tail, and then I'm going to follow the same pattern as before. I could get a tail and A on my spinner. I could get a tail and my B on the spinner. That's one outcome. And I could get a tail and getting a C. And that would be my entire sample space there. And I can see if I flip a coin and get a tail, and I do a spinner and get A, I have a tail and an A. There's my outcome in my sample space, and any other possible one should be inclusive in that sample space. It should be an exhaustive list. Okay, so the next way to organize things is with a grid. So sometimes a grid's useful here. So for instance, on this side, I might list the possibilities of flipping a coin. Okay, so I could get a head and I could get a tail. Okay, and then over here could be the options for my spinner. So I could get an A, could get a B, and I could get a C. So in my thing, here would be a head and an A head and a B, a head and a C. Here is a tail and an A, tail and a B, and a tail and a C. Okay, so you can see I still get the same sample space, but just another way of trying to organize my sample space to make sure I get all possibilities, but a little bit more efficient than making a list. Okay, so tree diagrams, okay, is a way to have our different options show up on different branches of our tree. So in this example again, we could have a coin and a spinner. Okay, so we can flip our coin and see that we get a head. So we can see that is here on my sample space. I can go ahead and flip and spin a coin. Spin my spinner and I get a B, and I can see that's right here in my sample space. So each end of the branch represents a unique sample space. Again, this branch here represents a B, or HA, a head and spinning an A, and the one we just got was flipping a head and spinning and getting a B. Okay. Notice we still get the same options here, just a different way of organizing things for our sample space. Okay. So if we're trying to illustrate using a tree diagram the possible outcomes when drawing three counters from a bag containing many red counters and blue counters. Okay, so because I have I'm drawing three counters, I'm going to have three levels of branches. Okay, so the first counter I pick, okay, first one, I could get a red. Maybe switch my colors. I could get a red, or I could get a blue. Okay. Now for the second choice here, okay, and second choice here, Each time I get another branch, I could get a red, here, or I could get a blue here. Okay. After that, I'm going to pick a third counter out of a bag. And so each one gets a branch, 1 and 2, 1 and 2, 1 and 2, 1 and 2. And then I'll put my reds on the top of each of those forks, knowing that I could get a red or I could get a blue in my second or my third choice. So I can see in this experiment I have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes, and each branch represents a unique different outcome, where let's say this branch here represents getting a red one on your first choice, a blue one on your second choice, and a blue one on your third choice. Okay, and all possibilities are listed here in our sample space with this tree diagram. Okay, so theoretical probability. The sample space when rolling a single die is 1 through 6. Okay, we expect that each outcome for that dice is equal. It's equally likely to occur. So we say, theoretically, the probability of that happening is 1 out of 6. Okay? So, theoretical probability is very useful for us because we don't necessarily have to conduct experiments and just do something over and over and over again, and we can really look at the theoretical mathematics behind some of probability. Okay, so we've talked about experiments, but now we're really going to look at theoretical probabilities. Okay, if the sample space has n outcomes which are equally likely to occur when the experiment is performed once, then each outcome has a 1 over n of it occurring. Okay, so if you have 6 sides of a dice and each one's just as likely, you get 1 out of 6 occurring. Okay. So let's look at how we can explain this a little bit more. So when the outcomes of an experiment are equally likely, the probability of event E occurring is given by the number of outcomes corresponding to E, okay, and the number of outcomes in the sample space. Okay, so a little different than our 1 over n idea, but sometimes the number of that corresponds to your event can be more than 1. Okay, so for instance, if I'm talking about picking cards out of a deck and I want to say that my event is picking a heart in a deck of cards, well, in a deck of cards there's 13 cards that have hearts in them out of a total number of cards, which would be 52. Okay, so this could be the probability of getting a heart in a deck of cards, where I look at the total number in my sample space. I have 52 different cards I could pick from. Okay, and the number that correspond to being a heart, well, there's 13 hearts in a deck of cards. So, an example is here. Okay, small child has a collection of shapes. She chooses one of the shapes at random. Find the probability that it's a triangle. So first, to find the probability that it's a triangle, I need to first know how many are in my sample space. So as I go through here, I see I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 different shapes that she can pick from. So I have 17 objects in my sample space. Well, of those 17 objects, how many of them are favorable, meaning how many of those shapes are triangles? Okay, so I'm going to go through and count my triangles. Well, I have 1, 2, 3, 4, 5. I believe I got all my triangles there, so it's 5 out of 17 is a probability of selecting a triangle out of that group of shapes. Okay, so in B, Okay, the child collects all the circles, then chooses one of them at random to give to her mother. So find the probability. Well, now the probability is a circle, but I'm given some information. So it's a circle, but only from my circle. So, I'm sorry, it's a circle, and I want to know if that circle is green. Okay. So when I look at these, no longer are these other shapes in my sample space. I only have those objects in my sample space. And I have 1, 2, 3, 4, 5, 6, 7. So in this, I have 7 in my sample space, 7 circles to choose from. How many of them are green? So I have 1, 2. So I have 2 out of 7 chance of picking a green circle if I know I'm grabbing from the circles. Okay. That concludes our notes for tonight. Please highlight any questions you might have and bring them to class tomorrow.